There are a couple of key AIME formulas that you should know for this problem. The first one is the formula for the sum of consecutive squares. This is n times n plus 1 times 2n plus 1 all over 6. The second formula you should know is that every number x can be written as the sum of its floor and its fractional part. We'll begin with this second formula by solving for the floor, which is x minus the fractional part of x, and we'll use that in this expression for u. So this floor is going to be equal to the number minus the fractional part of the same expression. Sums are commutative and associative, so we will split this into two separate sums. Let's tackle this first expression separately. We'll factor out the 1/5, and we'll split this up into two sums again, and factor a from the second term. We'll use our formula for the sum of squares, where n is equal to 2023, and this is just the sum of consecutive integers. We'll cancel out this 6 in the denominator and this 2 in this denominator. And we have two more factors that we can pull out, and this is an expression in terms of a of the first part of u. And we still have this fractional part. So now let's take a closer look at this second term. The fractional part of any number is going to be between 0 and 1. If we take the sum of 2023 of these, we're going to get a number somewhere between 0 and 2023. So to find the upper bound on u, we can let this fractional part be equal to 0. And let's approximate this fraction. This is approximately 400,000, and in our problem statement, we want this sum to be between negative and positive 1,000, which is way too big. So let's try to maximize the value of this second term. This is the upper bound of our fractional part. So the minimum value of u will approximate as 400,000 times this factor in terms of a, and then we'll subtract 2023. And we need this expression to be less than 1,000, our upper bound of our interval. Solving this inequality for a, and then approximating this, since a is an integer, let's start with a is equal to 1349, and we'll see what happens. Here's our expression for u again. This first term disappears when a is equal to 1349, so we're left with the negative of the sum of these fractional parts. To figure out what this sum is, let's take a look at a simpler example. Let's find the fractional part of a fraction where the denominator is equal to 5. N and a are both integers, so this numerator is an integer. The fractional part of this fraction depends only on the numerator, and it depends on the numerator in mod 5. So for example, in mod 5, 6 is the same as 1. So the fractional part of 6/5 is 1/5 because that's what remains in the numerator. So that's our motivation for finding the mod 5 residual of this expression inside the braces. For example, when n is 0 in mod 5, this numerator is 0 in mod 5. When n is 1, this becomes 1. 1349 is 4 in mod 5, so this is 2. When n is 2, 2 squared is 4. This is 1 in mod 5. This is 2 again. And when n is equal to 4, we get 0 in mod 5. To find this sum, we see that these fractional parts repeat every 5 terms. Let's just count the first 5 fractional parts. When n is equal to 1, that's 1 in mod 5. Our numerator is going to be 2 in mod 5, which means the fractional part is going to be 2/5. When n is equal to 2, our numerator is going to be 1 in mod 5, so the fractional part is 1 over 5. And so on for n equals 3, n equals 4, and n equals 5. Back up here. The sum of our first 5 fractional parts is 1. We're counting up to 2023. We have 404 of these groups of 5 plus 3 extra. So repeating this sum 404 times gives us 404 plus 3 more fractional parts, 2/5, 1/5, and another 2/5, which adds up to 405. Recall that when a was 1349, u was the negative of this expression, so negative 405. This is an integer, and it's in the interval. So it turns out we found our answer. We are asked for a plus u. That's 1349 and minus 405. And our answer is 944. If you'd like me to solve any other math contest problems, please leave them in the comments.